Right, so let's start now. So are you guys ready now? Hello? Are you guys already there?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
So again, before we'll start our meeting for today, do you guys have any question or clarification regarding with our module last meeting? Or with activities, quizzes, laboratories, anything? Any question? If you guys do not have a question, could you guys please give me a thumbs up if everything is clear? Right, so I'm seeing one from Mr. Zedrex. Okay, Mr. Kunanan. Okay, Mr. Antero, Mr. Brian, Mr. Ira James, Mr. Christian. All right, so if you guys do not have a question, then let us now start with our module 4. Okay. So again, let me just show this one to you guys. So this is the overview of your module 4. So this is where you can see the topic learning outcomes and then the list of topics. Okay, so as you guys can see, we have quite a few. So we have 1, 2, 3, 4, 5 for the number systems. And then we have number conversion and operations. We have sign numbers and then the computer codes. Okay. And then of course we have here the learning resources. We have here your PDF, which is the module for number systems, which I already uploaded, okay, in our module. And then we have here 2 video materials. So please do check them if ever you are confused in some part of our discussion for today. So, or you can just ask me right away. Like for example, sir, I didn't get this slide or this part. Could you please explain this one once again? So you can also do that one. Okay, so don't be shy to ask your instructor something like that. Okay, so it is not a big deal to me, but in fact, I'm quite happy if you guys will ask some question like that. Okay, and then we have here the reading materials. So this is a PDF, okay, wherein I've just found on the internet because the PDF that I'm using before is not available now. Okay, and I wasn't able to download that one, so I cannot find the exact PDF where my uh, PowerPoint or my presentation came from. So this is also a good PDF. Okay, so feel free to visit this one. It also explains some basic things, okay, when it comes to conversion of number system. So yeah, you may also check this one if you want. And then here's my references wherein mostly this one is already complete. Okay, so as you guys can see, this one is learn computer fundamentals. You have here the overview, applications and types, components, etc. etc. Okay, so we have here the decimal to the other base system, and then here are the steps that you need to do, okay, before you can convert such number. We have here other base system decimal. We have other base to non-decimal. We have decimal to binary, decimal to non-binary, etc., etc. Right? So yeah, that's it for the overview of the week 4. And here's the PDF. So please do download this one now so that you guys can have your own copy while we're having our discussion. Okay, and then I have also prepared. Okay, well, not actually prepared. I've just get some useful practice quizzes on the internet. So I've just attached here the link. So just left click this one, and it will lead you to a certain website where you can practice your number system. Okay, so please perfect this one. Okay, perfect this one first before proceeding to our quiz, which may be this coming Thursday, or this coming Friday. So I'm not sure yet. Okay. So as usual, we're going to have a quiz on Module 3 and Module 4 for this coming Thursday or Friday. All right. So are we clear with that one, guys? So
Yes,
guys,
sir.
Yes, sir.
just prepare again, okay? Thursday or Friday. Maybe Thursday, okay? Friday will be maybe another discussion or another consultation meeting. Anyway, so this is for the your laboratories. So I have added two, Lab 5 and Lab 6. So the due date or deadline of those two will be March 15. So you guys have exactly 1 week to finish the Lab 5 and Lab 6. Okay, so here's the instruction for the lab number 5. Well, this one is only short. Maybe this one will only take you 30 minutes, I guess, 30 minutes to 1 hour. So that's already enough. And then for the lab 6, so this is the one that is maybe quite long, okay, especially if you're not familiar with the usage of Microsoft Excel. However, this one is super easy once you have figured out how to do one row and one column. Okay, because you can do that one on the other columns once you have figured out one cell or one column, one row. Okay, so for the lab number 5, so you're actually going to create a letter. Okay, so here's the letter, and then we have some fields in here wherein it says you do not type the text. Okay, so where will you be able to do this one? So you will be able to do this one by inserting a letter. Okay. So actually all of the instructions are already in here. So just follow that one and then you will be able to come up with this one and that one and then this sample list. And then you'll be having those. Okay. We have here the title, the first name, last name, the title, last name, etc. etc. Okay, so this is like a pre-made letter wherein you will just put or you will just create a database. Okay, wherein the database will be stored as another file. Okay, so basically you're going to submit two file on this lab number 5. So the database and then the letter itself. Okay, so what is that database for? So that is the one that I will import to your letter so that once I click the preview letter or the preview, it will show here the first name that will came from your database. Okay, the last name that also came from your database, etc., etc. Okay, those enclosed field. All right. So if you guys have a question in the future, so feel free to ask me anytime, okay? Via Canvas or via Facebook account. So yeah. All right, so that's it for your lab 5 and then for your lab 6. So I guess we don't have a problem here. So all of the instructions are already here. So all you do is follow those and then you'll be able to finish this one perfectly. Okay. And if you guys have encountered the problem, so again, feel free to ask me anytime, right? So the viewing portion of the instruction here is not here. So if you will check that one on the Excel form. So oops, yeah, it is something like this. So we have the direction on the first tab, and then the second tab will be a sample format. Okay. So here's instructions to just follow this one, and then here's the sample format wherein it is look alike of the one that you're going to submit. All right. So are we clear so far?
Yes, sir.
Okay. So let me just tell you this
Yes,
one,
sir.
guys. So do not solve this one manually on the calculator. Again, the one that you're trying to practice here is on how to put a formula, okay? Like letting the Excel do the computation. So all you do is put the formula, okay, the row number, the column number, and then let it do the job, okay? So if I cannot see any formula in here, like the sine, secant, tangent, etc., etc., okay, so I'll give you a 0 on this one. Okay, so you guys must know on how to put a formula. You can start with column 1 plus column 2 equals column 3. Okay, so in that way, you'll be able to figure out how to, maneuver or how to configure such formulas. All right. So yeah, that's it for your lab number 6 and lab number 5. And then I have also prepared here a case study or discussion. So again, please do participate in this one. So we have here the facts and then the question. So I'll leave the reading part unto you guys. Okay. So it is now your job to understand what I'm trying to say in here. Okay, and then what I'm trying to ask in here. Okay, and then the due date of that one is also March 15th. So you guys have exactly 1 week to do those. Okay, give it is. All right then. So are you guys ready now to start with our discussion?
Yes, sir.
Yes,
Yes,
sir.
sir.
So let us start now. So I hope you guys made an advanced reading or advanced study with this one. All right, so as you guys can see, this the topic for today is number systems. So under number systems, we have 5. So starting with the decimal, binary, octal, hexadecimal, and then n-based system. Okay, so let me just give you an overview. What is this number systems? So when we say decimal, it is a count of 10. Okay, so when we say 10, it has a base 10. And then when we say binary, it has 2 numbers, okay, 0 and 1, okay, or it has a base of 2, okay. So as you guys can see, if we have a base of 2, it only has 2 characters, or it only has 2 values. If you have a base of 10, then it has 10 values or 10 characters. For octal, so from the word itself, octal, so 8, this one has a base of 8, okay, meaning this one has 8 characters. So 0 to 7, binary 0 to 1, and then decimal is 0 to 9. So as you guys can see, it's always less than 1 since we've started with 0. Okay. Hexadecimal is actually a base of 16. So if it's 16, so last one, it is 0 to 15. Right? And then we have here the n-base system. So if we have a base of, let's say, 13, then that is 0 to 12. If we have a base of, let's say, 6, then that is 0 to 5. Okay. So anything that is or that cannot be found on those base 10, base 2, base 8, and then base 16, we call that one n-base system. Okay, so it could reach from base 1 to base 15. Okay, and then we have here the number conversion and operations. So of course, in number conversion and operations, we're going to use addition, subtraction, multiplication, and then I guess there's no division. And then for design numbers, where you're going to learn on how to convert a positive, let's say, binary number into a negative binary number. Okay, that's why it's called sign numbers. We have positive and negative. And then lastly is computer codes or the ASCII code. Okay, wherein a decimal has equivalent of binary, binary is the equivalent of octal, etc., etc. So this is just actually like an ASCII code or a list of codes that you can find on the internet. Okay, so it's like a cheat code for us since direct conversion. So what is the octal of 8 into binary? So it will give you there. Okay. All right. So enough with the topics. So let's start with the digital circuits. So when we say digital, okay, it is actually binary in nature. Why? Because as you guys may all know, when we say digital, it only has 2 values, 0 and 1, or off and on. All right. And then we have the analog one, the other one, which is the it's varying from time to time. Wherein, yeah, it could start from 0 and then 1, 2, 3, 4, 5, and then negative 4, 3, 2, 1. So like for example, a sine wave. Okay, you could say that it's an analog because it has a lot of variations. Okay, unlike the DC wave wherein it only has positive and negative. So I guess that's the easiest way to explain when you see digital and analog. So analog has a variation or a varying value, unlike digital, it only has 2 value. Okay, that's why it's called binary in nature. Okay, but of course, it has several types of representations of numerical data are in use. Okay, like for example, okay, it's not only limited to binary, But it can also be represented by octal, by decimal, or by hexadecimal. All right. So let's start with decimal first. So again, just like what I've said a while ago, see decimal, it is 10 numbers or 10 characters, or it has a base of 10. Okay. So people use decimal representation to count. So digit is derived from the Latin word for finger. Okay. So digit means finger, and finger or our fingers has 10 numbers. That is why maybe we connected the decimal as 10, okay, or representation of our fingers. And then as you guys can see, since it's representing 10, it will only reach up to 9 since we will start with 0. So in every number, okay, in every number representation for binary, octal, decimal, hexadecimal, or any n base, so we will always start with 0. Okay. So again, let me just repeat this one. If we have a base of 10, less 1, so it only up to 9, since you will start with 0. If you have a base of 12, then that's 0 to 11, right? So yeah, that's it for the decimal. And then we have here the binary. So just like what I mentioned a while ago, when say binary, it's only 1 and 0. Okay, so 1 representing the on, and then 0 representing the off. All right. And then we have here the let's say how you read, okay, a digit in a certain number. Like for example, we have here a bit. Okay, so bit here actually represents one character. Okay, the smallest character that we can find on the computer. So we call that one bit. And then we have here nibble, where in nibble is equivalent to 4 bits. And then we have here the byte, which you guys may have always heard about. So byte is equal to 8 bits or 2 nibbles. All right. And then we have here the word, which is quite unfamiliar with you guys. But word is consists or equal with 2 bytes. Okay. Or in other words, this one is 16 bit. Okay. And then we have here double word. Well, this one's very straightforward. Just double this one. Okay. So from 2 bytes, it will become 4 bytes. All right. Or this 4 bytes is equal to 32 bit. All right. So we have here a number. Okay. So it's actually a binary number since this one is only composed of 0 and 1s. So we have here the lowest bit and then the highest bit. Okay. So this is your lowest bit since this is where you will start to read a number. Okay. Not from left to right, but it's from right to left. Right. So we always start with right. So it's now quite confusing. So you will understand later on why we'll start with right and not left. Anyway, so from the right, we have here the lowest. So 1, 1, 1, 0, 1, 0, 0, 0. So this one is actually 1 byte already. Okay. So if you're going to take a look at this one, we have 1, 2, 3, 4. We have 4 bytes in total. All right. And then one character, okay, is of course called a bit. So that is why if you're going to count all of those characters, we have a total of 32 bit. All right. And then we have here, of course, the word, okay, which is 16 bit. And then we have here the double word, which is a total of 32 bit. So were you guys able to follow so far and how to read, okay, a number on a number system?
Yes, sir.
All right. So I hope that you guys can follow. Anyway, we have here the decimal and then the binary. So the representation of the decimal is the same with our, with our numbers. So 0 is 0, 1 is 1, 2 is 2, 3 is 3. However, in binary, it's now represented by 4 bits. Okay. So actually, you could represent this one by 2 bits, but mostly we are using 4 bit. Okay. So if it's 0, then everything is 0. If it's 1, then it's 0, 0, 0, 1. Okay, if it's 2, we have 0, 0, 1, 0. So now how do we get this combination of numbers? Okay, so you guys might now confused on how did we get those equivalent from decimal to binary. Like 9 is 1001, So let me just introduce this one to you guys. So again, this is your 4-bit binary number, and then we have here the lowest bit, okay, and then we have here the highest bit. Oops. All right. And speaking of lowest bit, this one is or has a value, okay, of 1. Okay. The next one has a value of 2. The next one has a value of 4. And then the last one, or your highest bit, has a value of 8. Okay. So what are those values above? So those are the representation of decimals. Okay. So these are our decimals. So sorry for my bad handwritten. And then this is the representation of binary number. Now, when we say binary, so there's only 2 numbers that will come up with your mind. So it's only 0 or 1. Now, again, when we say binary, so when we say 0, it's represented by off. And if it's 1, it's represented by on. Meaning, in other words, if it's 0, then it's not active. Okay. If it's 1, then it's activated. Okay. So the count of that decimal equivalent must be counted. So when we say 0, so of course everything is not activated. Okay. So this one is equal to this one. When we say 1, then of course we will start with lowest bit. So we have to activate the lowest bit, which is 1. So 1, 0, 0, 0. All right. And let's say let's jump to 4. Okay. We have 4. Okay. So just look for the equivalent values. So as you guys can see, we have here the 4. So just activate that one. You don't need to activate 8 since it's more than 4. You don't need to activate 2. You don't need to activate 1 since we already have this one number. Okay. So 0, 1, 0, 0. And then let's say we have 7. Okay. So in here, you don't need to activate 8 since it's more than 7. So make that 1, 0. And then we have here 4. So yeah, you'll be needing 4. And then you have here 2. Yes, you'll also be needing 2. So just activate it. And then last one is 1. So as you guys can see, 4 plus 2 plus 1 is equal to 7. So this is the representation of binary from the decimal. So were you guys able to follow so far on how did we get those binary numbers? No, 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 no. You don't have to memorize each of binary representation of numbers. That's what do you call this one? Quite stupid actually. So sorry for the term. Though the only thing that you need to memorize is this one, right? Okay, so all you have to worry about is this one, the arrangement. So this one is actually super simple. So this is not like memorizing, but very natural. Okay, so starting from the lowest bit, you start with 1. Okay, so that's the only number that you need to memorize. And then the following numbers, you need to multiply the last number by 2. Okay, so 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. Then if you have one more, okay, let's say you have 8-bit, okay, 8-bit number system. You have here, of course, 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. And then 64 times 2 is 128, right? So as you guys can see, you don't need to memorize when it comes to binary numbers or binary representation. Okay, so we have here 8-bit numbers or 8 binary system. And then this one has a maximum of, I guess, 256. So if everything is activated on the 8-bit number system, this one is equal to 256 or 255. So just add all of those. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. You will get 256. All right. So are we clear so far with that one?
Yes, sir. Thank you, sir.
All right. So don't you guys worry. Binary to decimal is super easy, right? And then if you have more, then just keep on doubling the last number. So 128, 256, 512. So this is 5, okay, 512. And then 1024, and then 2048, and so on and so forth. So just keep on doubling that one. It's actually up to infinity. All right. So this one now is a total of 12 bit. Yeah, 12 bit binary representation. All right. So that's how we've got those values. Okay. So as you guys can see, this one is actually a total of 8 bit. Am I right? No, 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 no. This one is 4 bit only. So if everything is activated, so 1 plus 2 plus 4 plus 8 is equal to 15. 15 decimal. All right. So are we clear so far up to this point? So were you guys able to follow on how did we convert this decimal to binary? So that's the first step. Okay, that's the first conversion that you will learn to this number system. Hello? No, guys.
No, sir.
So any questions so far? Is there anyone there who's quite confused? Answer. All right. So I hope the others who are not responding right now is also getting this one. All right. So let's now move on to the octal. So again, from the word itself, octal. So it's 8, or it has a base of 8. But then again, of course, you have the last one since you will start with 0. So this one has a range of number from 0 to 7. Okay. And then take a look on this one. So yeah, you will start with 0 to 7, but then you don't have 8, 9, 8 and 9 in octal number system. So the next number is 10, 11 to 17. Okay, and then 20 to 27, and then 30 to 37, 40 to 47, and so on and so forth. Okay, so that's the thing that you need to take note when it comes to octal number system, right? And then here's the conversion. Okay, so 0, 1 to 2 is the same with the octal. Okay, up to 7 actually. So that's the same. However, when it comes to the decimal, okay, if we have here 8, the next one in octal is already 10. Since I have mentioned a while ago that we don't have 8 and 9 on the octal. So it's always like less 2, okay? If it's more than 7. Yeah, if it's more than 7, okay? So 9 to 15, and in octal it's already 11 to 17. Right, so you can just keep on going like that. Like you have to add 2 on the octal, so 9 here will become 11, 15 here will become 17. Okay, though this one is already quite rare. Okay, so as always, when we're having a conversion from decimal to octal, we're only needing 0 to 7. And then it's the same with octal, which is 0 to 7. And in some cases, yeah, we are reaching up to 10 maybe, or up to 12 or 15 of the decimal. Then you have to convert that one to octal. So yeah, just add 2 if ever that happens. So 8 will become 10 in octal. 13 will become 15 in octal. 15 will become 17 in octal, and so on and so forth. But then again, once you reach 16, that is now plus 4. Okay, so as you keep on going, so it will become plus 4, plus 6, plus 8, and so on and so forth. However, that is already rare. Okay, so we don't convert that big amount of decimal to octal anymore. Right? So yeah, that's how we convert octal number system. And then we have your hexadecimal. So from the word hexa, this one is representing a 16 base. Okay, wherein, of course, you will start with 0 and then up to 15. Now, you guys might be wondering why do we have A, B, C, D, E, F in here. Okay, so this one is to separate, okay, the 11 to 12, 13, 14, 15, okay, from the hexadecimal to the octal. Okay, since 11 to 15 is now being used by octal. Now, when it comes to hexadecimal, we cannot use those numbers anymore since it's already being taken by octal. Okay, so for us to be able to know that this one is hexadecimal, then your 11 or your 10 rather is now being represented by A. Your 11 is being represented by B, and then your 12 is being represented by C, and so on and so forth up to 15. Okay, so we have here the table. So 0 to 9 from decimal, and then to hexadecimal is the same, so no problem with that one. However, when it comes to 10 to 15, so that is now where A to F comes to play. All right, so are we clear with this one so far? Are you guys able to follow?
Sir.
Bigay ka na lang muna yung pagkain.
Ano yan?
Magdadala. Then, yung pala wala na si Mickey.
All right, so concerns? Any other concerns?
None, sir.
None, sir.
Okay. So just remember, if it's hexadecimal, it's 0 to 15 or 0 to F, right? All right then, so in here, as you guys can see, 0 to 9 is the same, and then 8 to F is also the same. And then we have here 10 to 19, which is now being represented by 16 to 16 plus 9 is 16 to 25. And then 26 right here is 1A, 1B up to 1F. Okay. Well, actually, this one has a pattern. Okay. So 0 to 9, and then 10 to 19, and then 20 to 29, I guess. Yeah, 20 to 29. And then 2A to 2A to 2F, and so on and so forth. So that's already reaching up to 30 decimals. So that is already a long range of number already. So we might not be able to reach that count of numbers anymore. So you don't need to worry about, say, what is 1A, what is 1B, what is 1F, and so on and so forth. But there are some numbers, there are some questions in your quizzes, in your exams maybe, that might reach up to 2F or up to 1F, okay? Just to have a harder, okay, representation from decimal to hexadecimal. Okay, so it is now your job to learn what is the pattern behind this consecutive numbers or consecutive representations from decimal to hexadecimal. All right. And since we don't have enough time anymore, so we will just continue the rest on the part 2. Okay, so we'll stop here for now and see you guys on the part 2. Okay, so goodbye for now.